Hi, in this homework help video I'll try to give you some advice and descriptions for completing homework 6 about testing and analysis of variance. The first problem I've assigned is the Berkeley guidance study for just the girls, the BGS girls data, and I want you to think about two competing hypotheses. The null hypothesis is that the SOMA, the expected value or the mean value of the SOMA variable, that's the body type score, is related as a function of age 9 information, weight, height, leg, and strength at age 9, versus an alternative hypothesis that has all of those age 9 variables plus the information at age 2. So really the issue is, does the age 2 information provide additional ability to explain SOMA variation after you've already adjusted for the age 9 variables? And I have defined both of those models here, the null hypothesis model, the alternative hypothesis model, and then I've invoked a test with the ANOVA command. And hopefully from the notes you will have seen this kind of ANOVA command before, and you'll understand the output that's produced. You get the residual sums of squares for each of the two models. You get the subtraction for the residual sums of squares, an F statistic, and a p-value. And I'd like you to use the output that's been provided here to make your test, putting in the test statistic value and the p-value, and then make a full conclusion about what these extra variables say about explaining somatotype. Problem 2 is again about the twins data, where there are 3 social classes, high, medium, and low. And I have several parts to this. Here's some scatter plots relating the IQ of the foster raised twin to the IQ of the biologically raised twin. And we have separate points according to the social class factor variable. And in this homework assignment, I've created 3 different models for you. Model 4, M4, just says that there is a relationship between the IQ of the foster and the biologically raised twins, but that relationship is the same for any social class. Model M2 is the main effects model. It lets intercepts change according to social class. Model 3 is a strange specification where we force the intercept to be the same for all social classes, but we allow the slopes to be different. And model M1 is the most general interaction model. And then we give summaries for each of the 4 models. And then I give some effects plots for model 4, model 2, the main effects model, model 3 that has different slopes but a common intercept, and then model 1 that allows separate slopes and separate intercepts. And then we go through a series of test commands with the ANOVA command, testing models that are nested within each other to see what models are supported. And then in problem 2a, I ask you to consider this particular model. Null hypothesis is model 4 against an alternative hypothesis, which is model 2. And you can see from the markdown file and here in the output file, I've automatically coded the right F value to go in this spot, and I've automatically placed the correct p-value here. It's bringing in an R variable and quoting it here, so you don't have to do anything about the F or the p-value. You just need to provide the correct conclusion for this test. Look at the notes for how to do that. Similarly, for problem 2b, same sort of thing. In this case, we're comparing model 2 in the null hypothesis against the more general model 1 in the alternative. And I've got the F statistic and the p-value placed here. You just need to make the conclusion. And then in problem 2C, I want you to review all of the output that I've provided and try to think about which of the four models, M1, 2, 3, or 4, do you think is the best representation for the data. And I want you to, tell me which model you think is the best one. Use the information in this section to make your decision. And then from the model that you've chosen, try to tell me what it says about the relationship and give me some sort of information about what kind of relationship structure there is and what it says about the biologically and foster-raised twins. In problem 3, we do the industrial experiment about the strength of wool based on 3 factors: length, amplitude, and load. We are going to consider a couple of different models here. Model M1, which you may not have seen this structure before. I've got length, amplitude, and load added together, and then I take parentheses and then square it. And that's just a shortcut for a model that has all of the interactions. MF is the main effects model that just has length, amplitude, and load, trying to explain the log of the duration cycles variable. M1 is a model that has length, amplitude, and load, and then all two-way interactions between, it'll have length by amplitude, length by load, amplitude by load, and then model M2 takes away a couple of those interactions and is only leaving us with length by amplitude. In problem 3A, I want you to test the hypothesis that model M2 is good enough in the null hypothesis, and model M1 is needed. We need all those extra interactions. That test is being done right here with the ANOVA command M2, M1. So give the test statistic, the p-value, and the conclusion about what you've decided. Follow the notes for how to do that. Problem 2B, I've given you the effects plot for model M2. Remember, model M2 is the one that has length, amplitude, and load effects, and an interaction between length and amplitude. You'll notice the effects plot has a more complicated length amplitude figure and then a simple figure for understanding load, because load is only appearing in the model as a main effect. From that effects plot, I want you to talk about what it says about the effects and what's going on. So from the graphical displays, the two that are given right here, talk about what it says about strength of yarn. Problem 3C asks you to appropriately use the ls means function. And so I've given you an ls means command for model M2, and what this command does is it compares the amplitude levels at a fixed level of length, and the level of length I want you to use in your analysis is the 350 level, and that's going to be this part of the output right here where length 350, and then we have 3 comparisons provided: amplitude 8 compared to 9, amplitude 8 compared to 10, and amplitude 9 compared to 10. And I want you to summarize how the amplitude levels, if there's any evidence of difference in response or average response across the amplitude levels for a fixed length of 350. So use this section of the output to discuss what's going on in the experiment. In problem 3D, I want you to use this ls means output, again from model M2, discussing differences between load, and in particular I want you to write a discussion about how 40 compares to 45. So load level of 40, how does that compare to the response at load of 45? Remember, we don't need to consider amplitude or length in the load analysis because amplitude and length don't interact with load, so you can just study the main effect for load. Here is the comparison of 40 to 45 right down here in contrasts, and I want you to use that in your discussion to say how these levels of load differ. You can see the basic summary for the load right in here, and that's what I want for 3D. Let me know if you have questions about this homework.